Balancing equations. To write a balanced chemical equation, first write the skeleton equation. Then we will use coefficients in front of each element or molecule or compound to balance the equation so that it obeys the law of the conservation of mass. Here's a balanced equation for making a bicycle. Maybe this will help you visualize it. The numbers are called coefficients. And let's see where we have a number. Right here. See the 2 over there? See the 2 over here? They are small whole numbers, integers, that are placed in front of the formulas in equation in order to balance it. So you have the same amount of fluorines, for example, on the left that you have on the right, or in this case, bicycle parts. Okay, so let's do bicycle parts. I said this was fluorine. It's not. It means frame. So we have one frame. We have 2 wheels. We have one set of handlebars, and we have 2 pedals. We put them all together, they react. There's our arrow. So here's your reactants. Just write an R there. And here's your product. And what do we have? We have one frame. There's one F. We have 2 wheels. We have one handlebar. And we have 2 pedals. And you'll notice on each side we have the same amount of frames, wheels, handlebars, and pedals. And that's due to the conservation of mass. We'll now leave the bicycle repair shop and talk again about chemistry. So we're going to use the reaction we've been dealing with, which is methane plus oxygen yields carbon dioxide plus water. You can see we've written to the right, they're all in the gaseous state. And now we're going to break apart each molecule and see how many elements we have. So for the CH4, we have 1 carbon, 4 hydrogens. We have 2 oxygens, 1 carbon, 2 oxygen, 2 hydrogens, and 1 oxygen. When we balance equations, we're going to put whole numbers, positive integers, in front of each molecule or each element so that on the left side, the reactants, we have the same amount of carbon atoms, hydrogen atoms, oxygen atoms, whatever, that are on the right side. Mass is conserved. Let's balance our first equation. This is going to take some practice so you can learn the tricks to do this. So let's just start off. We have methane plus oxygen again yields carbon dioxide and water. So what do we have over here? Let's not look at this 2 over here and this 2. Let's just pretend they're not there for a second. On the left side, you have 2 oxygens. Again, ignore the whole number in front. On the right side, you have 1, 2, 3. So I need more oxygens. So the first thing I'm going to do is multiply this by 2, and you can see the 2 there in the circle. So that now gives me 4 oxygens. Okay, that's pretty good, but I only have 3 on the right side. How can I make that equal 4? Well, that's where this 2 comes in. So now I have 2 oxygens, a total of 4 oxygens. I have 2 there and 2 there. So that's good. 4 oxygens on the left, 4 on the right. Let's see if that solved the problem for us. 1 carbon on the left, 1 carbon on the right. 4 hydrogens on the left, and let's see. How about that? 2 times 2, I have 4 hydrogens, so it all checks out. Those numbers, those 2 2's we put in, those are called coefficients. Your equation is now balanced. Mass is conserved. Here's our complete equation. And again, you see the gas, and you see the 2's we put in. Okay, those are the coefficients. They tell the number of representative particles, which can be atoms, molecules, or formula units. And all the coefficients do is they change the amount of compound or molecule. Subscripts indicate the number of atoms of each element in a molecule. If you change the subscripts, that would change the type of compound or molecule. So we're not going to be doing that. We're going to be changing the coefficients to balance the equations. Here's a nice way to look at using, frankly, a physics illustration. We're balancing masses on either side of a point there, a fulcrum. We're balancing the torques, letting the torques equal 0. But that's for physics. Let's go to chemistry. If we look on the left side, if we just write it like this, which was our skeleton equation, we have 2 hydrogens as reactants and 2 chlorines. The product, though, there's only one hydrogen and one chlorine, so that's represented by this picture. You can see how it's weighted more to the left side. It is not balanced. Now when we balance it, we put a coefficient of 2 in front of the HCl, the hydrochloric acid, and now we have 2 hydrogens on the left, the reactants, 2 on the right, the products, 2 chlorines on both sides, and look how nicely it's balanced. And it wouldn't work with the physics because the masses are different, but this is a great illustration. That's why we call it balanced. We've just pictured it as balancing on a fulcrum there.